Here we're going to look at how to transform a quadratic function. So the question is, how are transformations of the graph of f of x equals x squared related to an equation representing another quadratic function? We have something called vertex form, and vertex form shows three different ways in which the graph of the function f of x equals x squared may be transformed. This equation right here is our vertex form. We have a, h, and k values, and each of those will cause certain types of transformations depending on the values of a, h, and k. So we'll just go in order. Let's start with the a value. If you have the absolute value of a is greater than 1, you're going to have a vertical stretch. If the absolute value of a is between 0 and 1, then you would have a vertical compression. So it'll depend on the actual value. You want to be careful. Sometimes we assume that a fraction is automatically between 0 and 1. That's not always the case, but you do want to look at whether it is greater than 1 or between 0 and 1 to determine whether it's a stretch or a compression. And then a also causes a reflection in the case where if a is negative, then there is a reflection over the x-axis. So three things can happen because of a. There can be a stretch or a compression. You can never have both. And then there's also the possibility of a reflection. All right, now looking at the h value. The h value is the one that's a little tricky. It's backwards. So if we are subtracting h, let's fix that. If we have something where we are subtracting h, there's going to be a shift right. And if we were adding h, the screen is not cooperating with me today. If we add h, there will be a shift left. And then finally, our k value. The k value is the easiest one to understand. It's very straightforward. So plus k would be a shift up. And minus k would be a shift down. So there are 7 total transformations or possible transformations. The a value can cause stretches, compressions, or reflections. The h value is your horizontal changes or shifts, which will go left and right. And your k value are your vertical changes or vertical shifts going up and down. So now let's take a look at example part A, where we have g of x is equal to negative 1/2 times the quantity x plus 2 squared. So the negative value here is going to cause a reflection. So anytime a is negative, there will be a reflection over the x-axis. Now the 1/2 is also going to come into play. This is getting rather annoying. The 1/2 will also affect something, and that also comes from a. The 1/2 tells us whether there's a stretch or a compression. 1/2 falls between 0 and 1, so this would be a vertical compression. By a factor of 1/2. And finally, we have this plus 2 on the inside. And that plus 2 is our h value. H is inside the parentheses, k is outside. So plus 2 is going to tell us there's actually a shift to the left. So our graph would shift left 2 units. Now, if we look at the actual graph that they've provided for us, the parent function is the blue one. Well, our vertex goes 2 places to the left. The graph is then reflected. It's flipped upside down. So that's where we have this reflection, that a value. And then finally, we have a vertical compression. And when you compress it from the top and the bottom, that's why your graph gets a little bit wider. Think of it as like you're squishing it from the top and the bottom. So you can visually see the transformations there. All right, let's look at part B. In part B, we start with a 2, which represents our A value. 2 is greater than 1, so that would be a vertical stretch by a factor of 2. Now, for these type of problems, we're only going to be talking about vertical stretches and compressions. So if you just say a stretch by a factor of 2, it's not the worst thing in the world, but understand that there are the possibility of horizontal stretches and compression. We just won't be working with them in this context. The -1 is our H value. Remember, that's the one that's backwards. So if we're subtracting 1, it's going to be the opposite. So this is actually going to be a shift right 1 unit. And then finally, we have this -3, and that tells us there will be a shift. This is the easy one. It does exactly what it looks like. It's a shift down 3 units. All right, and those are the transformations for part B. Now, if you look at the actual graph, we had the original parent function in blue. And if you take a look at your vertex went one place to the right, and then 3 units down. So it's now here. And then there's a vertical stretch. So think of this as pulling it from the top and the bottom, and that's why it becomes more narrow, or looks like it's kind of been thinned out. So that's it for your transformations in terms of vertex form with A, H, and K. There are 7 possible transformations, 3 coming from A, 2 coming from H, and 2 coming from K. So make sure you're familiar with those 7, and you should not have much trouble with this topic.